Hello, I'm from Team Dregos, and this is our second coding tutorial of our series. In this lesson, I'm going to teach you how to turn by gyro. Now let's get started. Now, your robot has a sensor that tells it which direction it's pointing at. So when your robot is facing forward, this is something called yaw. In this case, when it's facing forward, it's called yaw equals 0. When you're programming your robot to turn, you will want it to turn the exact angle. The angle your robot turns is measured in degrees. Let's say your robot wants to turn to the right. We will call this a 90-degree turn. If we wanted to turn to the facing the opposite direction, that would be 180-degree turn, or a 90 plus 90-degree turn. If you want to turn and face the left, you could do 90-degree turns to get to the left. But that would take way too much time. So let's get there in a faster way. This way what we have to do is we have to turn to the left, which would be a negative. So when you're turning to the left, it's going to be a negative number. If you're turning to the right, it's going to be a positive number. Alright, here's an example of how it's going to turn. If two wheels are going in the exact same direction, in this case, two paddlers are going in the exact same direction, it's either going to go forwards or backwards. But if one is rowing down and another person is rowing up, it will start to turn. Yep, it's going to turn. Now, your robot is the exact same way. If one wheel is rotating one way and the other wheel is rotating the other, it will start to spin. Now, before we get started, there are some math concepts that we should probably know. Those are greater than, equals, and less than. Like 2 is greater than 1, and 1 is less than 2, and 1 equals 1. Now, next is the directions. We talk about left being negative terms and right being positive terms. Like negative 30 is left turn, or negative 60 is a right turn. Now, the absolute value of negative 90 equals 90. Or, I missed that, but it would equal negative 90. The absolute value of 90 is 90. And again, here's what it would look like. Now, in our code, before we get to there, our wheel speed might be 50%, or however big it should, however fast you want to go, with the speed direction. Now, whatever whatever degree you are turning, if it's a positive, it will take the number, and if it's depending on if it's a positive or negative, it will multiply that and give you and find out how fast it has to turn. Now, here comes recursion. Now, don't worry if this is going to be confusing. This is like a university thing, but don't worry. Here we go. Now, the code that we're about to use, it's gonna go through these different things. Eventually, it'll come to this orange block and realize I'm gonna have to copy myself. So then it's gonna come to here and it's go all the way back down and say, oh shoot, I have to copy myself again. Now, after we go to as many codes as it needs to, it will eventually come here and say, oh, wait, I don't need to code myself. I'll get to the bottom, which is the pink stuff. I can just skip to the bottom, get to the pink stuff, and then come back. Then the code will come to the pink stuff, then this will cancel out and come back. This code will come here. It will eventually, it will find out which way it has to go, and it'll head straight back to the code. Now, let's get started. Alright, in our last video, we worked on setup. Today, we're going to be working on turn by gyro. So proceed to my blocks and click this button called make block. Now, you want to call this name turn by gyro. There you go. And now you want to grab an input. Now you want to call this input degrees, spelled D-E-G-R-E-E-S. Alright, grab another text and call this degrees at. Grab another input, call this turn power. Another text, call and give it percent power. And it should sort of look like this, depending on if it's capitals or not. But after that, click save, bring it down here where it's not as close to the setup. First, then you want to go into controls, not operations, controls. Grab an if, then, else, and put that right under there. Then you want to go into operators, grab an or, place it in here. And if I'm going too fast, you can pause whenever you want. But grab an if, else, and an or. Now you want to grab an arrow that's pointing to the right. Place it in the first block. Grab a degrees. And instead of 100, we're gonna name it 180. Now grab the same thing, but arrow pointing a different way, or not an arrow pointing a different way. Grab an equals. Put in third power. 180. Bam. There you go. Now, here, if in between here, when it says this, then here, we're gonna skip that part and grab another if then else. After that, we want to grab another or, so we're essentially copying this. Instead of grab the different direction arrow pointing to the left. And again, you're basically just copying the bond. Now grab an equals. Don't forget to turn this into 80, 180. Grab an equals. Instead of degrees, make a turn power. There you go. Now essentially what this is doing is it's saying if what you just punched in, what number you pushed, is greater or is less than 180, or the turn power is 180, then do this. Now again, this is where the recursion is going to come in, but we'll do that later. And again, same thing here. But if But if the degrees is less than 180, or the turn power equals 180, then we're going to do, again, recursion. But instead, we're going to skip these two and go to else. First, grab yourself, go into sensors, yaw angle equals 0, and put it under else. Then go into more extensions and grab more movement and go into there. Now if this is spike, then you want to grab something that says set movement acceleration to medium. Put that under there. Now you want to make it, and you want to set it to default, or actually don't set it to default, set it to slow, so then you get it's more accurate, and it's very smooth. After that, get a wait for, put it under. Now depending on how long you want to wait, each turn that you make will cost how long you wait. Now, sometimes it might glitch out, so my suggestion, 0.25. So if you were to have 4 turns, that would equal 1 second that you're wasting. Alright, go into more movements, grab start movement at that. Then you want to grab division symbol in operations, so it's going to look like a slash or something like that. So grab this, bam, place it in there. Now you want to grab the degree symbol and place it in the first hole. Then go for the second one, go into here, grab the absolute of. Place that in there, and you also want degrees. So this is just saying degrees divided by the absolute amount of how much degrees you put in. Now, before we move on, grab this this thing that looks like a star and just take out what we just wrote right there. So instead of it being degrees divided by that, take that out, put the divisible in there, and then you're gonna put what you just wrote into the first hole. Now the second hole, you're gonna put turn power in there. Now we're gonna be doing the same thing. Grab another division or another multiplication that looks like a star, place it in there. Grab a division and place it in the first hole. So it should be looking like a slang thing. Grab a degrees. Then you want to grab the absolute of. So again, we're copying that. Okay, absolute of degrees. And then grab a subtraction. You know what it should look like. Put it in the second hole. Then you want to place it in a 0. And then grab yourself a turn power. There you go. So, what we have done right here is, if we go back to our slideshow, let me just pull it up real quick. Yeah. What we just made is this pink stuff here. So once the recursion has happened, it is just copied and copied and copied. Then it will say, oh, I don't need a copy anymore. It's going to go to the code. And then it's going to do all the math, which is, if we go back, there we go. if we go back, take the degrees and divide it by the absolute of degrees. Then multiply by, one sec, I have to sneeze. Turns out I don't have to sneeze. And divide it by the turn power. Now it's essentially doing the same thing, but it's just saying subtract that by the turn power. Alright, now go until wait until, and it should look like that. Put it under the start movement at. Then you want to grab yourself an arrow pointing to the right. Okay. Then you want to grab an absolute. You want to grab two absolutes of, place them there and there. Okay. So just keep it absolute. But after that, you want to go into sensors, and and the default should say pitch angle, but you can change it, and you want it to go to yaw. Now remember, yaw is the direction, and yaw is just showing which angle it's pointing at. Grab the yaw angle, place it right there. Now the absolute of, just quickly grab a degrees. Now grab a minus real quick and replace it, place the other one and put the absolute of degrees in the first hole of the subtraction. Now here, where I just put 7 right there, you can change that up, and all that essentially is doing is just all it's doing is just how many more degrees should I turn. Now it could be 0, it could be 10, depending on how your wheels have set, or your motors. If it's your wheels, it's probably greasy. If it's your motors, it's probably if they're like stuttering or something. Anywho, back to our lab. Go into movement. So scroll up into movement. Get stop moving. And there you have it. Okay, now that we have this pink stuff, when the code is done recursion, we now need to do the recursion stuff. Go into my blocks and grab this. This right here is the code that you're going to be using for the rest of your turns. Trust me, it works so much. So again, just remember, negative is going to be turning to the left. Positive, you should just leave it alone. It's going to be turning to the right. The turn power is going to be depending on how fast you're going to go. If you go over 75, I would say, then you're going to go. Then it's not going to be as controlled, and you're not going to get exactly where you're going to want. But if you go under 25, then you're going to get there at a slow time, but it's going to be like directly where you want to go. So first, we want to copy those and place them in each if else. So go like so. Then you want to grab a minus in operations. And there you go. Now grab a degrees and put it in the first hole. And then grab 90. So now this is saying turn by gyro, and then the degrees subtract. So again, recursion. So it's going to see this. It's going to be like, oh, I got to make a copy of myself. And it's going to be so fast that you can't even see it. And it's not even really going to waste any time. So don't worry. The only thing that is going to waste time is just FWay 2.5. Now, don't delete it. because if you do, then it's gonna start to cause problems. So just keep it in there. And again, you can change this to how fast you want it. Let's just keep it at where you think you is where you think where you think you should put it. Now, second hole, you're gonna grab turn power. Because again, turn power doesn't make shouldn't affect anything. It's mainly the degrees. But the turn power is just gonna show how fast it is. Now grab yourself a plus, put it in the first thing, but under. Grab degrees, plus 90. Just pause 90. And again, turn power. There you go. There you have it. There is a chain by GYRO. Now again, this is for Lego Education Spike. If you have Lego Education's like the other app, there will be some other things. Anywho, there you go. There you have it. There's your turn by GYRO. And let's say we want to put this into some code. Let's say I want to turn 45 degrees to the right. I'm going to put 45 degrees. Let's say I want it to be direct. So a good suggested power would be 50, or you can go 60 if you want to get there faster. There you have it. There's turn by GYRO. I'm from Team Dregos. This is the end of our video. Goodbye.